Welcome to Calbeckistan, the place where anybody can learn math. My name is Mr. Calbeck, and today we're going to be learning about solving rational equations. Now, if you've been watching the other videos in the series, they've all been about expressions. But today we're going to be talking about equations, and there's a couple of main differences between those. First, equations have an equal sign, which allows us to do some different things, including the golden rule, which you'll see used later. But it also means that you can actually solve for x, which means we're trying to get x by itself. In expressions, the only thing we're really trying to do is to get the simplest version of what you see. So you're going to try to simplify things, cancel stuff out, but in an equation we want to solve. So in this video today, if you are not familiar with how to add, subtract, multiply, divide fractions, you're going to want to watch videos on those first, link in the description. I'm going to give you two methods today on how to solve these. Either of them work for any problem that you see. So you can kind of try both of them and see which one feels better to you. They're about the same level of difficulty as well. So these first two we're going to do is probably going to be the most familiar strategy. So let's take a look at this problem. What we see here is we've got two fractions on one side and one on the other. Just like in any other rational expression, you're going to want to combine things together, and in this case, you see I can add two fractions together, so let's just add them together, just like you did when you're adding rational expressions. So we're going to need to find a common denominator here between 6x and 2x. Now, one method that always works is to multiply the denominators by each other, but there's a much easier way here if you think about it for a second. And the question is, what can you multiply by 2x to turn it into 6x. All right, I hope you guys all saw that it's 3. We can multiply this by 3 on right here, and it would turn into 6x. Now, real quickly, for those of you who haven't seen these videos before, you can't just multiply whatever you want. The only thing you can multiply a fraction by without changing it is 3 over 3. And the reason it doesn't change it is because you're actually multiplying by 1. Anything multiplied by 1 is itself. So let's go ahead and simplify this. Keep in mind, anytime you have more than one term in a fraction, put parentheses around it, which will help you remember to distribute the 3 into both terms. So that gives you 1 over 6x plus 3x plus 12 over 6x. And now we can just combine like terms. The denominators are the same, so I just have to combine my like terms. 1 can't go with 3x, but it can combine with the 12. So let's go ahead and add those together. 1 plus 12. Again, we can write this as one big fraction if you like first. You see 1 plus 12 is going to give you 13. So we can rewrite that as well. So this is what we're left with. The problem before we solve this is that we have x in the denominator. That's a problem. We need to get x out of the denominator before we can actually solve for it. And the nice thing about this is that it's an equal sign. So we can actually do the opposite operation to both sides. And we can use the golden rule. So let's remember here, a fraction is really just a division problem. Try not to panic when you see these. They're division problems. So this is being divided by 6x. All I really need to do is do the opposite of dividing by 6x, and I need to do it to both sides, according to the golden rule.
That's what you do to one side, you must do to the other side.
So I'm going to multiply both sides by 6x. You see here, because I'm doing the opposite, it will cancel out. You can also see 6x, and 6x makes a big 1. Let's see if I can draw a big 1 here. Yeah, now that's a big 1. But they cancel out, right? And then over here, I'm going to multiply by 6x as well. So these cancel, which then leaves me with 3x plus 13 and no fraction. That's nice. And that's going to equal 7 times 6 equals 42x over 3x. Now I hope you guys can see here that we have another big one. X over x will cancel out. That makes another big one here. So those cancel as well, leaving you with 42 over 3. 42 divided by 3 is 14. So you can rewrite that as 14. Now you have a question that pretty much any 7th grader could solve. Subtract 13 from both sides, and you've got 3x equals 1. Divide by 3, and you get x equals 1/3. Okay, and that's our final answer on this one. All right, here's our second example on using this method. Again, we want to combine our like terms together first, and then see if we can do the opposite to both sides. So let's go ahead and see if we can add these fractions on the left side first. And again, we want to see if we can simplify things without making a really complicated denominator. And I can see that x and x squared are pretty close already. So if there's a way I can multiply by 1 to change this x into x squared, I've got a common denominator. Now x and x squared, if you multiply this one by x over x, that's what we're looking for. It's going to give you a common denominator. X times x is just x squared, and 5 times x is just 5x. So those go ahead and simplify pretty quickly, and that leaves you with 5x over x squared. Now you've got a common denominator. You can go ahead and add these together. You've got 5x plus 4x minus 8 over x squared. Combine like terms. And 5x and 4x combine together to make 9x. So you can just go ahead and write that in right now on your paper. So we get 9x minus 8 over x squared equals x plus 3 over 4x squared. Now what we want to do to solve this, again, remember these fractions are division problems, and we have to get x out of the denominator before we can do anything else. But since they're division problems, we can do the opposite of division, which is multiplication. So if this fraction is being divided by x squared, you guys can multiply it by x squared to cancel that out. Remember, this is all in parentheses, so I can multiply this side by x squared. And that makes a big one. It cancels out over here. And I have to do the same thing to the other side. So I'm going to multiply this side by x squared. Now in this problem, the really nice thing is these x squareds make another big 1. They cancel out, and you're left with some really nice problems here. So you're left with 9x minus 8 equals x plus 3 over 4. Now I'm going to show you one more trick that I like to do with this to make this even easier. You can solve it from here. It's a little bit more of a complicated problem. This would be a little bit more of a challenge for an Algebra 1 student to figure out. But if you remember, again, the division is what fractions are. These fractions are just division problems. So if you remember that, you can do the opposite of division on this part of the problem too. This is all being divided by 4, so I'm going to do the opposite to both sides according to the golden rule.
That which you do to one side, you must do to the other side.
And if I do that, if I multiply this side by 4, because it's being divided by 4, it cancels out. And now my fractions are completely gone. I'm left here with a 4 on this side. And again, remember to put everything in parentheses. It's going to save you so many times. And remember to help you distribute. So at this point, you guys can solve this. Distribute the 4. You're going to end up with 36x minus 32 equals x plus 3. And that's your problem. This is a much easier problem to solve now. I think you guys can manage it from here, but I'll walk you through it. And 35 divided by 35 is 1. And that's your answer, so x is going to equal 1. And again, let's walk through this. You want to remember the steps. You want to combine your like terms. Okay, so you want to add your fractions together and multiply both sides by whatever the denominator is. That will get rid of the x in the denominator and allow you to solve this. In this problem, we actually multiplied by a second denominator there. Again, there's no rule against that. You can multiply by as many things as you want, so long as you do it to both sides. So that's kind of your trick on this one. Your second method I'm going to show you in a minute. Before we jump into anything really challenging, I want to show you the principle with a simpler case of what we're talking about here. When we find a common denominator on two fractions on both sides, some really interesting things happen. So what we see here is a mystery number being divided by 4 equals 7 divided by 4. If I asked you to solve for x, most of you would probably realize that, well, x has to be 7. And you'd be right. Whenever I've got a number divided by 4 equals another number divided by the same number, what's happening here is that these two have to be the same. They're both divided by the same number. Now you can actually do this pretty easily. You can show with algebra pretty easily. Just like we did on the last one, we multiply both sides by 4. Let's do that here and see what happens. If I multiply this side by 4, cancels out. I have to follow the golden rule, do the other side, multiply this side by 4, which also cancels out, which equals 7. So when you can multiply both sides by the same number, you follow the golden rule, and in this case, it cancels out the denominator. So when your denominators equal each other, when you multiply them, they completely cancel out. And that's essentially the principle that we're going to use for this next problem here. If we can find a common denominator between everything, we know that the numerators have to be equal to each other for this same reason. So let's look at a new problem where we can apply this. Alright, here we are. So this is a big, ugly problem. Like always, when you're dealing with a rational expression, you want to factor everything. The same is true with a rational equation. So I'm going to see if I can factor everything because it's going to tell me some good information here. X squared minus 7x plus 10, these are already the same, so I can only have to factor one of them. And x squared minus 7x plus 10, looking for two numbers multiply to be 10, add to be negative 7. Hopefully you can see that it's x minus 5 and x minus 2. So let's go ahead and rewrite this with the factored forms in here. So once I have this, you can see that it's actually not too difficult to get a common denominator between everything. This has an x minus 5 and this has an x minus 2. This has already got the same thing. And this has got an x minus 5. So all I really need to do is give this one an x minus 2, and I've already got a common denominator between everything. So in order to do that, I'm going to multiply by x minus 2. Again, I have to do the same thing to the top because I can only multiply by 1 without canceling anything out. So what I'm left with here is I've got x minus 2 minus 1 equals 4, and now I have a common denominator between everything. X minus 2, x minus 5, x minus 5, x minus 2. So now I have a common denominator between everything. And what I'd really like to do with this is see if I can combine some like terms. So up here I've got x minus 2 minus 1. I don't really need the parentheses here anymore, so I'm going to get rid of those. And I can just combine my like terms. So the x won't combine with anything, but the negative 2 and the negative 1 will combine. That's going to give me x minus 3. So here is my fraction that I'm left with. Now, here's the cool thing. I could multiply both sides by the same denominator if I wanted to, just like in our simple example, which would cancel them out, leaving me with just the numerator. Since these two are exactly the same, you know that the numerator has to be the same as well. So you can actually, again, cancel all these out because you multiply them by each other, they divide out, which gives you x minus 3 equals 4. And takes a really terrible looking problem and makes it really easy. So then we have add 3 to both sides, and you see that x equals 7. Hope you followed that. We're going to do one more example just in case. Alright, here's our last example for today. So what we want to do is see if we can find a common denominator between everything and then simplify the top. So what we've got here, as I can see, there's an x squared and an x squared and an x. And so really, we can find a common denominator pretty quickly just by multiplying this one by x. Do the same thing to the top with our big 1. Remember, this is in parentheses. Be careful there. So we can multiply those all together, which then is going to give me x times x is x squared. If you distribute the top, you end up with x times x is x squared here. X times 2 is 2x. So this is our new equation with a common denominator between everything. Now remember, when you have a common denominator between everything, we can go ahead and combine our like terms. So there's not really any terms to combine here, so I'm just going to leave. Again, a 2x doesn't combine with a 1 or an x squared. So all I can really do is write it like this, plus 1. So what I've got here is x plus 1 equals x squared plus 2x plus 1. And again, remember last time, if you have the same denominator on both, you could multiply by x squared on both sides if you want to, which cancels them out. Everything's gone. Again, it cancels out because it divides into 1. So if you have common denominator between everything, really all that happens is your numerator is equal. Alright, and now what we're going to have to do here is we're going to find a way to solve this. If you remember solving quadratics from your freshman year, in order to solve one, you need to get 0 on one side. So we're going to go ahead and do that by subtracting x, subtracting 1 from everything here, which leaves me with 0 on one side equals x squared plus 1x plus 0. When you have a problem like this, there's a couple ways to solve it. You can complete the square, you can factor, or you can use the quadratic formula. This one's really easy to factor, so let's do that. This has a common multiple of x, so we've got x times x plus 1 here equals 0. And I can use the zero product property. So I'm going to go ahead and do that. Again, zero product property says if I have two numbers that multiply together, they're going to equal 0. One of them has to be 0. You don't know which one, so you have to check both. But you can write two quick equations. You can say x equals 0 or x plus 1 equals 0. So you can get two answers here. X equals 0, you don't have to do anything there. Or if you subtract 1, you get x equals negative 1. So two answers. Here's the problem. Sometimes you can have issues with an answer in a rational equation. Because remember, in your original problem, the denominator could never be 0. So once you solve these, you need to plug them back into the original equation to make sure that none of them give you 0 in the denominator. Now if I plug negative 1 in here to the denominator of x squared, I don't have any issue. Negative 1 squared gives me a positive 1. It's not 0. So this one is good. But if I plug 0 into the denominator, 0 squared is 0. Since that would give me 0 in the denominator, this one is not allowed to be in the problem. It's called an exclusion.
Sorry about that, guys. The video cut out. I don't know why. But anyway, what I was going to say is in that problem, 0 becomes an excluded value because when you plug it back into the original equation, it gives you 0 in the denominator. That's a problem. So since it gives me 0 in the denominator, I know it can't be one of the answers. So just keep that in mind. When you get a couple of answers, check them at the end. Anyways, and again, sorry about the weird video too. For some reason it was recording in black and white and made all the contrast weird. So anyways, hope you could at least watch it. I tried to change with some filters. Anyway, good luck. Sorry I can't be there today, but I'll see you guys soon.